Like your left hand and your right hand, which are mirror images, some molecules have mirror images that are not exactly superimposable. The set of lectures in this playlist describes some of the implications and ramifications that we experience in organic chemistry with organic molecules that have this property, which we call chirality. So after an introduction to the concept of chirality, the second lecture will talk about what we call pairs of compounds that are mirror images but not superimposable, enantiomers, and the term we use, configuration. And the next lecture will talk about molecules that are a little bit more complicated and have two different carbons that cause this type of chirality. And for those molecules, there are more stereoisomers, and in addition to enantiomers, it turns out they have diastereomers. And for special cases, there are compounds called mesocompounds. So we have enantiomers, diastereomers, and mesocompounds, and I'll cover the basics of those stereoisomers in those early lectures in this playlist. Then I'll talk about the only physical property that is different between mirror images that aren't superimposable, enantiomers, and we call it optical activity because of the way it affects light. And because you might begin to wonder if all of this subtle stuff about stereochemistry is really important, I've included a lecture on the significance of chirality, both with respect to chemistry and with respect to biology, including the activity of pharmaceutical drugs. So it turns out that chirality is very important, and you'll understand that. And finally, in the last lecture in this playlist, I'll talk about the way we separate these special compounds called enantiomers, whose only difference is that they are mirror images of each other.